Hello and welcome. This is part 2 of module 5 in which we're looking at functions, right? In part 1 we had covered the basic structure of a function, what functions really are. We looked at uh, passing arguments to functions, like positional arguments, variable number of positional arguments. We saw named or keyword arguments. We also saw like a variable number of named or keyword arguments, right? Then we also saw return values from the function where we could return no values or one value or multiple values using collections. So in today's lesson, we're going to look at nested or inner functions along with variable scope, right? So this is the foundational block to understand that I can have an inner function within an outer function. From there, I'm then going to cover this concept called closures. And then finally, we're going to look at decorators. Don't worry about anything. I'll explain those things as they come. But for now, let's start with nested or inner functions and variable scope, right? Now, I'm sure you've heard the word scope in a lot of different cases. So, what exactly do we mean by scope, right? So, just think of scope as area of operation, like which variables are accessible in which areas of the program, right? That's what we mean by scope. Now, you might think, like, why on earth do we need inner functions or nested functions, right? uh, and I told you initially when we spoke about like this introduction to functions, like there are lots of cases where we have a piece of code or some processing that has to be done multiple times, and instead of repeating it each time, we write it down, define it in a function once, and then we keep calling that function, right? So in a sense, it makes it more modular. Now, if you move that same concept one level deeper, now within the same function also, I could have multiple, like an operation that is repeated multiple times, right? And I need to move that operation into an additional function one level deeper. So that's called a inner or nested function. So if you look here, I have the def keyword to define the outer function, right? And let's just say it doesn't take any arguments right now. Now, inside the outer function, I use the def keyword to define another function, and you can see that it's at one level of indentation, right? And then what's inside that inner function is at the second level of indentation. So I can do whatever processing I want inside my inner function. And then when I move back to one level of indentation, I'm back to the outer function. So now I have defined this inner function here. I still need to call it, right? So I call it over here, or I can call it wherever it needs to be called inside this outer function. Then let's say I print some value and then I return control to the global, to the main program in Python where I'm calling the outer function. So if you think of this entire thing as the main program, this whole thing is the outer function, right? So I've defined the outer function, and over here I'm calling the outer function. I have the function name followed by open and close brackets, right? So what Python does is it passes control and moves into this code block inside the outer function. And there it encounters this nested function that has been defined, right? So the function has been defined, and immediately after that, that function is called. So when that function is called, the code inside that function gets executed. So this print inner function gets executed first. After that, control returns here, and we move to the next statement where outer function then gets printed. So that brings us to the end of the outer function, and then control is back to the main program in Python. So that's how uh, outer and inner functions work, right? So coming back to this discussion of scope, right? So what is inside this inner function is called local scope, right? It's basically if I declare a variable inside this inner function, that would be in local scope, right? Now, if I defined a variable as part of the outer function, so somewhere here, let's say right next to this print statement, above or below this print statement, then that would be enclosing scope, right? Because the outer function is enclosing the inner function. And if I declared a variable in the main program, that would be at this level here, then that would be called global scope. So we've spoken about global, we've spoken about enclosing, and then we've spoken about local. And the final place where Python searches for variables is the built-ins module, right? Which is the Python built-ins module, and that is called built-in scope. So the order in which it goes is, so let's say it encounters a statement inside the inner function called uh, print x, right? So first it searches for the variable x in local scope. Then it will go one level higher and search for it in enclosing scope if it doesn't find it in local scope. And even if it doesn't even find it in enclosing scope, then it goes one level higher and checks for it in global scope. And if it doesn't find it in even global scope, then it looks for it in the built-ins module in Python. So this is the order in which it goes, LEGB, that is local, then followed by enclosing, followed by global, followed by built-in, right? Now, that is the order in which Python searches for variables. But another important thing is to understand what can be accessed where, right? Now, the simple rule of thumb is what's on the inside can access what's on the outside, but not vice versa. So what that means is from within this inner function that is in local scope, I can access variables from this inner function. I can access variables from the outer function. I can access variables from global scope. I can access variables from built-in scope, right? I can access everything. But once I go to the outer function, I can only access the outer function variables, global scope variables, and the built-in variables. I cannot access what is in the inner function. Similarly, if I go one level further outwards towards the global scope, then I can only access global variables and built-in variables, not even the variables from the enclosing scope. So remember, inside can access outside and not vice versa. So in much the same vein, this outer function, right? This definition was in global scope, right? So from the main program, I can call outer function, but I cannot call inner function because inner function can be called only inside outer function. It's not directly accessible to global scope. So let's take an example here, right? Now, just take a moment to understand this example. I've set up quite a few different things over here. I'll give you the basic structure, then we'll run it once and you'll see what this output means, right? So again, in this case, I have an outer function that's defined in global scope. Inside that outer function, I have an inner function, and this inner function is being called in the outer function once it has been defined. And then in the global scope, I do some processing, right? And I call the outer function. Now, the first thing is I have set up a variable x in all three scopes, right? So there is a variable x in global scope, there is a variable x in enclosing scope, and there is a variable x in local scope. So we can see what value of x or which variable x is printed in which different scope, right? Like if I print x in this inner function, what gets printed? If I print x in the outer function, what gets printed? And if I print x in global scope, what gets printed, right? And in addition to that, I've set up three other variables, right? So x underscore global is a global, it's a variable defined in global scope. Similarly, x underscore outer is a variable defined in enclosing scope, and x underscore inner is a variable defined in inside the inner function. So basically local scope, right? So I'm going to show you how to access these different variables in different scopes as well as edit these variables, right? So let me just take you through it, right? So the first thing I'm going to do in global scope is I'm going to declare x and x global, right? And this x global I'm going to access from all the way in over here as well as over here. Then what I'm going to do is I'm going to call the outer function, right? So then this whole block of code over here gets executed. So it's already been defined, now it gets executed. And then finally I print out the value of x global after calling the outer function. Now let's look at what's in the outer function. It's like a reflection of what happens in global scope, right? So I'm defining a, copy of the variable x. I'm defining another variable called x outer. and I'm printing both these, after which I'm defining an inner function, right? Now, the interesting thing here is, if you look at this statement here, right? What I'm doing is I'm reading x underscore outer, which is this variable in the enclosing scope. I had declared it here, right? But I'm accessing it here in the inner scope, innermost scope directly. So I don't need to do anything special to access an outside variable from inside. Similarly, I'm also printing out this x underscore global directly in the innermost scope, right? So I declare it here in global scope, but I'm accessing it here in the innermost scope with no special operations. So inner can access outer and outermost, but not vice versa, right? So now let's say I've finished defining this inner function inside the outer function, right? So now I'm calling inner function. And let's say below that, if I try to like access x underscore inner from here, right, from the enclosing scope, that is, I'm trying to access an inside variable from outside, Python will throw an error. It won't let you do that. It will only let you access variables in the current scope and above, but not below. So the outer function can access only variables defined in the scope of that function, not in the scope of the inner function. However, if I print x dot global here in this outer function, it will access it peacefully because x dot global is in global scope, right? So I will be able to use it over here. So let's just run this, run a few variations of it and see what outputs we get, right? Copying it and pasting it here. So if I run it using Control Enter, you can see that X in the global scope takes the value that I've put over here, right? I'm printing this value. Then when I pass control to the outer function, it says I've entered the outer function and now it's printing the value of X in the enclosing scope. So when I say X equal to local scope string and I print this value of X, what Python does is I print this value of X. What Python does is it searches for the variable in that current scope, right? So right now we are in the outer function. So when I'm saying print X, it's looking for variable X in the current scope, which is inside this outer function. If it doesn't find this here, then it will go to the X in global scope. So X in enclosing scope, we've got this here, and then we enter the inner function, right? And in local scope, it's got its own value here, which is the value we defined here. And you can see that I'm printing X underscore inner, X underscore outer, which is enclosing scope, and X underscore global, which is global scope, all from within the inner function, right? And I'm accessing them directly. And then what happens is I call this inner function inside the outer function, and I print x dot outer, and then I finally print x dot global, right? And the reason I'm doing these two things is because in the next variation of this, I'm going to actually edit these outer variables from the inside. So I think you've understood, right? Like inside this innermost function is local scope. One level above that is enclosing scope, and one level above that is global scope, and one level above that is built-in scope. And we go from the inside out in terms of searching for variables. Now, let's say I wanted to edit uh, from the innermost function. Let's say I want to edit these two variables, x underscore outer and x underscore global. They're not directly there in the present scope. They're one level above and two levels above, right? So how do I bring them into, so I can't just say x underscore outer equal to something. Python will throw an error there. So if I do x underscore outer equal to some new value, right? Let me just try this and run it again. Python should throw an error because I do not yet have edit access to this variable from the outer scope, the enclosing scope. So if I run it now, you can see that an unbound local error has been thrown, right? Similarly, if I try, let me just comment this out, right? And if I try changing x dot global similarly, right? If I try changing x dot global from this innermost scope, let's see what Python does. I'll run it. Again, it throws an error, which is the unbound local error, which basically means that I'm trying to do, like, there is an access control issue, right? I'm trying to access something that I don't have access to. So let me comment this out, right? So I want to change x underscore outer and x underscore global inside this innermost function. So the way I do it is I first bring x underscore outer in to this scope by using this statement, non-local. So first I have local scope, then I use the non-local keyword to bring in this variable x underscore outer, right? So this statement basically says I'm bringing this variable into my current scope to edit it. And then what I do is I now change the value to x underscore outer changed, right? So when I print it out over here, you should see the new value. So let me run that and show you. Sorry. Ah, so let me comment out this line here because this non-local declaration has to be the first line after which I can access it. So if I don't plan on editing it, I can access it directly. But if I do plan on editing it, then this has to be the first declaration after which you can access the variable. So let me also, yeah, so I'll run it now. And you can see that when I entered the outer function, the value of x underscore outer is this value, right? Outer. But when after I've exited this inner function and I come back out to the outer function, x dot outer now has a new value, which is x underscore outer changed, right? Which is what we did over here. We basically, inside this innermost function, we brought x underscore outer in to this scope by using the non-local keyword, and then we changed its value, right? So the value of the original variable has been changed, not some local copy. The value of the original variable has been changed. Similarly, I was reading the value of x underscore global. Let's say I want to change the value of x underscore global, right? So what I'll do is I'll bring x underscore global into the current namespace, into the current scope using the global keyword. So non-local refers to enclosing scope, global refers to global scope. So global x underscore global. So I'm now bringing that variable into this namespace using so that I now have edit access. And now I can change this value x underscore global to x underscore global changed. So when I print it out here after calling outer function, this should reflect the new value over here. So let's run it now. And you can see that x global before calling outer func was just this global value, and x global after calling outer func was this value changed. So I've shown you how to edit outer variables from the inside, right? And I've shown you that I can also access them directly. Similarly, I told you, right? Inside can access outside, but not vice versa. So in this outer function, if I try accessing what is in the inner function, let's say this x dot inner, right? I had defined it over here inside this inner function. Let's say I try to access something from this inside scope from the outer function. Then it should throw an error. And there we get it, right? We get a name error because Python doesn't know what x underscore inner is. It's only looking at the current scope and upwards. So let me comment that out again. So I can't access the inside variable from the outside. But I told you I can access the outside variable from the inside, right? So from the outer function, x underscore global is still outside. So if I print it, I should get its value here. So what I get here is this value, right? Which is x underscore global. So I have got in both cases, in the innermost scope as well as in the enclosing scope, I've shown you how to access variables either at that current scope or outside, but not one level inside. And also in what happens is in the outermost scope, which is a global scope, I cannot access x underscore outer or x underscore inner because again they'll throw errors because the scope is one level below and not at the same level or above. So I hope that gives you an idea of how variable scopes work. I hope you've understood what the non-local keyword is and what the global keyword is. So global keyword is used to bring a global variable into this particular scope for edit access. The non-local keyword is used to bring a variable in the enclosing scope into this current scope for edit access. Then I can change the value. If I just want to read the value, I can access it directly without using non-local or global. And just like I can access from the innermost scope a variable from any scope outside, the reverse does not hold true. Okay, so let's do some exercises to sharpen our understanding. Now define an outer function that takes a list as input and returns a list of pairwise products of adjacent list items as output. So what does that even mean, right? So it's like, let's say I have four items, right? One, two, three, and four. What is the product of the first pair of items? 1 into 2 is 2, right? So the first item in the output list will be 2. Now the second and third items are 2 and 3. So 2 into 3 is 6. So the second item of the output list will be 6. And similarly, 3 into 4 is 12. So the third item of the output list will be 12. So it will be 2, 6, and 12 for an input of 1, 2, 3, 4. We also have to define an inner function that calculates the product of a pair of numbers and returns it to the outer function. So I'm going to say define pairwise prod of LST, right? I'm going to take the input as a list of numbers and define this outer function. Now the outer function has an inner function that just calculates the product of two numbers. So I'm going to say prod of x comma y, right? Those are two numbers and I'm going to return the product. So x into y. And where does it get returned to? It gets returned to the outer function from where it's called. So now I have defined this inner function inside the outer function and I will call it only where necessary, right? Now this outer function has access to this list variable, which is the input argument. So what I'm going to do is I'm going to iterate through the list using the index, right? And I'm going to like look at the item at index value I, let's say, and in index value I plus 1. And I'm going to pass them to the product function, which is this inner function, and get the product. And that particular value I'm going to append to the output list, right? So I'm going to say output list equal to an empty list, and then I'm going to start appending values to that. Now for I in, and I've already shown you the range function, right? So I can say range of len of LST, right? That would give me numbers from 0 to n minus 1. But I'm looking at each number and the number right next to it. So I need to go from 0 to range of len minus 1 here inside. So I stop at the second last item, and in the last iteration of this list, I multiply that second last item with the last item, which is I plus 1. Now for each index in this range, 0 to len minus 2 basically, I'm going to say output list dot append, and then I'm going to call the input function, the inner function prod, with the values list of I, comma, list of I plus 1. So I is this index over here where we're going from 0 to len of list minus 1, or since it's range, we're going to len of list minus 2, right? 0 to len of list minus 2. So to the output list, I'm appending the item at the current position multiplied by the item at the next position. And how am I getting that? By passing it to the prod function, which is defined over here in the innermost scope, right? And at the end of that loop running, I have this output list which is populated with the pairwise products. Now I'm just going to return it back to where the outer function was called from, output underscore lst. So now if I call this from here, right, I'll say print pairwise product of, let's say I pass a list 1, 2, 3, 4, which is the example I took initially, right? And I run it. I get the answer as 2, 6, and 12 because 1 into 2 is 2, which is the first value. 2 into 3 is 6, which is the second value. And 3 into 4 is 12, which is the third value, right? So similarly, if I do, let's say I do, instead of 1, 2, 3, 4, I'll do 2, 3, 4, 5, 6, and I run it now. I get 6, 12, 20, 30. Basically n minus 1 items. So this is how you define an outer function that takes this input, an inner function that processes this input, and then within this loop, we're calling the inner function repeatedly and appending to the output list. Okay, so this is, I mean, it might seem a little complicated, but just remember the thing about scope, right? What exactly is scope? It's area of operation. Remember, what's on the outside can be accessed from the inside, but not vice versa. Remember LEGB. And remember that you actually have to call this input function inside the output function. You don't just define it. Now let's move on to the second example. In global scope, there's a variable called a with the value phi, right? So let me just say a equal to phi. So this is global scope, what we're in right now. Now define an outer function that contains two variables, x and y, with values alpha and beta respectively. So I'll say define outer function. I don't need to take any inputs. Now I'll say the outer function has two variables, x with the value alpha, x equal to alpha, y equal to beta, right? Now define an inner function that contains the variable y with the value gamma. So I'll say define inner function within the scope of this outer function. And I'll say in this inner function, the value y equal to gamma. Now in the inner function, I want to change the value of the enclosing variable x to delta. That is, x is currently alpha. How do I change it to delta, right? I want to change the value of the global variable a to phi phi. So a is just phi. I want to change it to phi phi. And then concatenate them with this local value of y and return it. So I'll say y equal to gamma. That's the local copy of the variable y, right? So the first thing I'm going to do to bring this variable into this inner scope so that I can edit it is use the non-local keyword, right? So it's an enclosing scope. So non-local X will bring X into the current scope. Now I'll edit that to this new value of delta, right? Similarly, I want to bring this variable A from global scope into this innermost local scope to edit it. So I'll say global A. And finally, I'll say A equal to phi. So I've edited X, I've edited A. X was in enclosing scope, A was in global scope. Now I want to concatenate them, these two variables, with Y and return. So I'm going to say return A plus X plus Y. Right? So I'm concatenating these three things and I'm returning it. Now, where does it get returned? It gets returned to the outer function, right? From this outer function, I'm calling the inner function. And it says now in the outer function, return the value from this inner function. So I don't just have to like, so the way I would explain it to you is saying inner function output equal to, I'm executing the inner function here. So it's the name followed by open and close brackets. So the entire thing gets executed. And that output from the inner function, I'm returning back to global scope where I'm calling this outer function from. So I'll say return inner function output, right? So that's the end of these functions. And now I need to call this outer function from global scope. So I'll say outer underscore func and open and close brackets. So I'm calling the outer function from global scope. Before that, I had already defined A on the outside, X and Y in enclosing scope, Y, X, and A in local scope. X was brought in using the non-local keyword. A was brought in using the global keyword. So, so what I should get is basically A plus X plus Y. Now, which value of Y is taken? It's the one in local scope, not the one outside. The one in local scope is gamma. Which value of X is taken? It's the same X which we brought in using the non-local keyword. Which value of A is taken? It's the same value here that we got from here, right? We got it here and then edited it. So now if I run it, this is what I get. A is phi. The value was changed from just a single phi to a double phi, right? X is delta. I changed it here. The original value was alpha. And gamma is the local scope y variable, not the enclosing scope y variable. So that kind of demonstrates which variables are accessible where, right? So you now learnt about nested or inner functions. So you have an outer function, you have an inner function, and the inner function is called within the outer function. And you have all these different variable scopes. Now let's look at another concept called closures, right? So this is really, really important because like closures are like these utility items, right? You can use them to empower other people who are writing code using like the libraries you built. So they're called factory functions. Basically, I showed you what inner functions are. Closures are a very specific form of inner functions, right? So now the first thing to remember is in Python, functions are first class objects. I kind of briefly touched upon this in the previous video, but when I say first class objects, what I mean is just like all other data types, they can be stored in variables. They can be passed to a function as an argument. They can be returned from a function as the return value, right? So closures are basically nested or inner functions that kind of are stamped with some variable from the outer function. So there are three main requirements, right? There is an there is an outer function and then there is a nested or inner function. The inner function has to refer to a variable in the outer function and the outer function has to return that inner function. So what I'm saying is, in effect, when I call the outer function, I am getting a function returned to me. So I'm kind of passing one input. The outer function is taking that input, it's creating this inner function with that input, and it's then returning that inner function to me. So let's just say I want to create a function that uh, like it lets me create square functions, cube functions, and so on, right? So what is the thing that changes over here? It's going to be the exponent, right? So let's say I call the exponent function to basically create this thing called a square function, right? So if I what exponent does is exponent is the outer function, right? It takes this input called power. Then it has an inner function called calculate, which takes an input called num, right? All we do is return num exponent power. So num to the power of this power variable. And where is this power variable? It's outside, right? So in a sense, this function definition depends on the value passed to the outer function. So these conditions are met, right? There is an outer function and there is an inner function, which is the first condition. Second condition is the inner function refers to a variable in the outer function. So this variable is from the outer scope, and the outer function returns the inner function, which is here. So the three conditions have been satisfied. So square function, so you can think of the function returned as an avatar, like it's a version, right? So square function is the version of this input function having the power value equal to 2. So it will return num to the power of 2. Similarly, cube function is the version or avatar of the inner function stamped with the power as 3. So it returns num to the power of 3. That's basically what it means, right? So the variable that you're creating here is the avatar of this inner function with a certain value for this power. Now, if I want to find, let's say, 9 square, what I'll do is I'll just say square function of 9 or square function of 10. And what is a square function? It returns num to the power of 2. So 10 to the power of 2 will return 100. Cube function of 3, which is basically num to the power of 3, which is 27. It took me a couple of iterations to uh, basically understand closures well. Okay, so don't feel bad if you're feeling a little confused right now. We can just repeat this part of the tutorial a couple of times and you'll get it, no problem. So the way to use closures, and these outputs are just as I told you, right? Square function of 10 will give me 10 to the power of 2, which is 100. Cube function of 3 will give me 3 to the power of 3, which is 27, right? So let me just explain this again in a slightly different way, right? So the first thing I'm doing is when I define a closure in this particular way, the first thing I'll do is, let's say, step 1, right? Step 1, create a version of the inner function that we need. Example, let's create one function for let's say 10th power and one function for 20 for 11th power. Okay, so how do I create a version of this inner function that returns the 10th power of a number, that is a number to power 10? I have to fix this power value as 10, right? So how do I fix that power value as 10? I basically pass 10 to the outer function, because that will return a version of the inner function where power is fixed as 10. So I'll say power of 10, or let's say to the 10th power. So this variable contains a function, right? That function is a version of this inner calculate function where the power value is fixed as 10, which basically means I call this function with the input 10. So I'll say equal to exponent of 10, right? So now to the 10th power, what I've done is I've created a new function. Remember this. If I call this outer function with a certain input, I'm basically creating a new version of this inner function with with that same input, right? So to the 10th power equals exponent of 10. Similarly, to the 11th power equals exponent of 11. So I'm passing 11 to this outer exponent function so that I get back a version of this inner function where power is fixed as 11. So the step one is to create a version of that inner function that we are interested in, right? Step two, use these newly created functions to do our calculations. And what was here earlier, I'll just move it up, right? So in our step one, we created a version of this inner function that we want. In step two, we are using these newly created functions to do some calculations. Let's say I print to the 10th power of which number do I want? Do I want to supply whose 10th power I want to find? Let's say I want to find 2 to the power of 10, right? So what I get here is 1024, which is 2 to the power of 10, right? So I created this function called to the 10th power by passing 10 to this exponent function, which is the outer function. I then calculated 2 to the power of 10 by passing the number 2 to this newly created function. Similarly, if I do to the 11th power of 2, I'll get 2048. So you're kind of doing it in two steps, right? The first step, let's say step 0 is to define this outer function that has an inner function, right? The inner function refers to a variable in the outer function. So the outer function is kind of returning a version of the inner function with this value fixed, right? So that's the initial step. Then what we do is we create the versions of this inner function that we are interested in. Like in this case, we wanted the 10th and 11th power. And then we call these functions with the values that we want processed. So let's see how to use this practically now. Create an outer function that returns a function. So if you want to create an outer function that returns a function, that's basically a closure, right? To calculate the nth power of specific numbers. When you call the outer function, you should fix the base number whose powers you want to find. When you call the returned function, you should be able to find the different powers of the base number. So it's like saying, first I'm going to create a function, something like powers of 25, where I'm fixing the base value of 25, right? And then I want to pass 25, then pass 2 to this to find 25 squared. And if I pass 3 to this, it'll be 25 cubed, right? So this is basically what I want. So let's say I define an outer function, right? I don't even want to get specific and write random names for it. Let me just call it outer function that takes the base number, right? And then I define an inner function that just takes, let's say I want to find the, like I want to specify the exponent. So I'll say exponent, right? Now this inner function returns base to the power of exponent. And remember, base is what I pass to the outer function. So if I want to say powers of 25, I create a function where I call outer func with the value 25, right? And what it does is it returns an inner function where the number 25 is fixed. So the inner function basically takes an exponent and returns 25 to the power of that exponent. And now I need to return this inner function, right? And remember, I'm not returning it like this. I'm just returning the function itself without the brackets. So now I'll say powers of 25 equal to outer func of 25, right? So I've created a function that's going to calculate the different powers of 25. So when I say outer function of 25, it returns a version of the inner function where this base variable is set as 25. So now if I call powers of 25 with the value 2, then it should return 25 squared, right? Because this inner function has this base fixed, but the input that it takes is the exponent, right? That is the power. So we're passing power as 2 here, and I'm going to print this value. That's exactly what we get, 625, right? So I want to find the third power of 8 and the second power of 25. Now in this case, I've already found the second power of 25, right? So let me use the similar setup to find the third power of 8. Third power of 8 is basically 8 power 3, right? So the base number is 8 and the exponent is 3. So to create this version of the inner function with base fixed with 8, I'll say powers of 8 equal to outer function of 8. So I've created a version of the inner function with base fixed as 8. Now I'm going to call this returned inner function and pass the exponent value to it. And I want to get the third power of 8, right? So I'll say print powers of 8 and I'm passing the argument 3 to it. So 8 power 3 is 512, right? So I found the second power of 25 and the third power of 8 using closures. Now let's look at the second example. Create an outer function that returns a function. So an outer function that returns an inner function that echoes a word n times, right? So basically there is a word and then there is the output, which is that word repeated n times, right? So when you call the outer function, you should fix the number of times you want the word echoed. So for example, if I want, so I would do something like uh, echo 5 times equal to, let's say I'm outer function, I pass 5, right? So that's returning a version of the inner function that echoes 5 times. And now to the inner function, I have to supply the word that I want echoed, right? So now I'll say print echo 5 times of whatever word, let's say test, right? And the output I should get is test, test, repeated 5 times, 4, 5. Right? This is the output that I expect. So this is what I'm trying to basically do using this exercise, right? And then I needed to echo the word hello 4 times and the phrase hey can you hear me 5 times. So when I say 4 times and 5 times, I have to create two versions of the inner function with values 4 and 5, right? So let me just comment out this initial thing. Now I'm going to say define, uh, I'm going to say echo, right? And in the first case, I'm going to fix the number of times uh, that I want the word echoed, right? And there is an inner function called, let's just call it inner function, that takes the word that you want echoed, right? And now I'm going to return the word into echo, right? So if you use the multiplication operator on strings, uh, then the string gets repeated n times. Sorry, not into echo, into num. So num is the number of times I want it echoed, and word is the word which I want echoed, right? So now if I think about how this works, and obviously this has to be returned, this inner function itself has to be returned by the outer function. I'm not calling it by opening the brackets, I'm just returning the inner function object. So the first thing is I want to echo the word hello 4 times. So I'll create a function called echo 4 times, which is echo, and I'm supplying the argument 4, right? So what this does is it returns a version of the inner function with number fixed as 4. Similarly, echo 5 times echo of 5. So this returns a version of the inner function where num is fixed as 5. Now I'm going to call these newly created function to get my output. So in the first case, I'll say print of hello, right? So echo 4 times of the word hello, right? And I'm also going to print echo 5 times of the word, of the phrase, can you hear me? Now if I run these, you can see that hello is repeated 4 times, or it's echoed 4 times, and hey, can you hear me? 3, 4, 5 is repeated 5 times. So echo 4 times is basically a version of this inner function where the outer variable, that's num, is fixed as 4. And echo 5 times is a version of this variable with num fixed as 5. So then we can call each of these specific versions of the inner function with the word that we want echoed. So that brings us to the end of closures. So we've seen nested functions and variable scope. Then we saw a very specific use of nested function where the outer function has an inner function. The inner function refers to a variable from the outer function, and then the outer function returns the inner function. Now the last thing we look at is decorators, right? Now let's recap a couple of concepts so that you can understand decorators better. The first is functions are first class objects, right? So they are objects like any other objects. You can store them in variables, you can pass them to functions, you can return them from functions. The second thing is we looked at nested or inner functions today, where you have a function inside a function. And in the third case, we looked at closures, where uh, you have an inner function that's returned by an outer function that remembers the state of the outer function, right? So basically, it's a version of the inner function that remembers a particular value from the output function, from the outer function. Now, there are times when you might want to modify the behavior of a function, right? But you might, like, when you're writing code on your own laptop, nobody is going to stop you from modifying a function, right? But what if you're writing code in some big company and like there's a lot of sensitive stuff in the production environment, like people are not going to let you modify the source code of functions that easily, right? But there are cases where you might want to implement additional features and functionality, and the company still has to progress, so you need those features, but at the same time you cannot let everybody just access the original source code functions, right? So that's where decorators come in, right? So decorators are a way to wrap a function around the original function, so you extend or modify its behavior in some way, right? So for example, let's say I have a function that does some operation, right? What if I want to implement access control or authentication? Like that operation should be allowed only for users who are logged in, let's say. So I want to add that element of authentication to the original function. Or let's say I want to the debugging or logging of the function is terrible. Let's say I want to add some functionality where I say this is the time at which I started executing the function and this is the time at which I finished executing the function, right? So that's audit logging. The third thing could be like rate limiting. So you've heard in AP, like whenever you sign up for an API, right? There's always these terms and conditions, and different tiers of pricing will have different levels of uh, rate at which you can call the API, right? So if you pay more money, obviously you can call the API more times per minute. Now, if you want to kind of rate limit the the rate at which resources can be accessed, then you might have to modify the behavior of the function, right? So the original function still behaves the same way, but you want to add this element where a person can only access it that many times in an hour or that many times in a minute. Or if you want to implement, let's say, caching, right, to utilize resources efficiently. So for example, the first time a function is called, you run the original function and also cache the uh, output from that function. And the subsequent times the function is called, you just return the cached output without having to rerun the entire function all over again. So these are different cases where you might want to modify the behavior of an original function, right? Uh, and decorators are the best way to do it in Python. So remember, decorator is a wrapper function. Okay, so it wraps around the original function and modifies its behavior in some way. And remember, like there might be one decorator for access control, there might be a second decorator for audit logging, there might be a third decorator for rate limiting, there might be a fourth decorator for caching, and you can apply multiple decorators to a single function. Okay. Uh, like one decorator could make the text uppercase while the other can change all the punctuation to exclamation marks, whatever. Like uh, a good thing to do maybe as like in a production environment or these like enterprise development environments would be to save your decorators uh, in a separate module and then just importing them as and when needed, right? Now Python has a lot of built-in decorators, but we'll focus on creating new ones from scratch. Now I'll explain the concept using some like pseudo code. Okay, you have a function to be modified, right? So let's say this function to be modified is this code, right? So I'm defining function to be modified and I have some code inside the function, right? Now let's say I want to change its behavior in some way. So I'm going to define a decorator function that accepts this function as the input, right? So the decorator function accepts a function as input. Then it defines an inner function where you do all these additional activities. Like for example, let's say I perform some rate limiting, right? Or I perform authentication. After that authentication, I execute the original function which had been passed to the outer function. So you remember in the case of closures, the inner function accesses some variable from the outer function, right? So that's exactly what we're doing here. We're calling the function, executing it, and then finally there might be some code to be executed after executing the original function, right? So there's some code before, then there's the original function, then there's some code after, and now you're returning this particular function, right? So it's the exact same concept as closures. Only thing is, in this case, you're using it to modify an original function. There you were using, in the previous case, we were using closures to return some version of the inner function that remembered some values from the outer function. In this case, we're using it to return a wrapper function which modifies the behavior of our original function. So remember, we have this original function here, right? We have a decorator function here. Now this decorator function accepts a function as input. So ideally we're going to be passing this function in here. Then we're going to be creating a wrapper function, right? Which basically does the before the pre-processing, then the original execution, then the post-processing, and we get this wrapper function returned. So you're passing this as the input to the decorator, and you're getting this modified behavior as the output function, right? And this new function that is returned is what we're going to be calling subsequently. So I'm kind of saying I'm changing the value of this object to the modified value of this object. So I had this original value of function to be modified, right? Which was this. Now, by passing it to the decorator function, which is here, I get a modified function with a wrapper function around it, right? And that's what I store in the same variable name as this. So that's effectively what I'm doing with a decorator, right? I'm changing the original function to now contain the new returned version of this inner function. So this is one way of doing it, but there's a much more precise and a much easier way of writing it. So the same thing that I had done here is also defined here. The same function that I had defined initially is also here, but instead of assigning it to the same variable and then calling that same variable again, all I'm doing is at decorator function, which is the name of this decorator function, and I'm writing it in the line above the function definition, which is here. So I'm defining the function as I did before, and before uh, defining the function that I want to modify, I'm just writing the decorator name with an at symbol in the line above. What it means is that this decorator function is now applied to this function. So the function is now modified. That is, this function got passed as an input to this decorator function, and what we get is this modified behavior. So now when we call this, what actually gets run is not just this, but it's this. Okay. So let's now work on building our first decorator, right? I'll show you this example. So I'm creating this define get current date time function to get the current date and time, right? So let's say I get a timestamp and I'm using the date time module for this. So I'm importing date time and I create a variable called now, which gives me the timestamp as of this moment. So datetime.datetime.now. You don't need to worry about the exact intricacies of the datetime module. I'll be covering it in a later chapter. But I'm just saying I'm creating a timestamp, right? And I'm returning that timestamp formatted as a string. So the same variable now, which is a timestamp, I'm doing the strf time function, which is a string format time in this form, like year, month, date, space, hour, minute, second. So it's just giving me a timestamp, right? The current timestamp. And I have a decorator function. Let's say I want to log the date time before and after function execution, right? So let's say my original function is I want to get a quote by Steve Jobs saying this design is not what it looks like and feels like. Design is how it works, right? So the original function returns this Steve Jobs quote, right? Now, this date time logging decorator, what it does is it takes a function, and in this inner function, First, it prints the function name, right? And this function name is what we had passed to this outer function. And how we access it is func dot so this is called the double underscore name variable, right? So it's an attribute of this object. You remember when I use the dir uh, method, like for example, if I say dir of uh, string, let's say, and I run it, I get all these attributes and methods, right, which we had seen in module 2 or 3, I think. 3. So these are all the attributes and methods, right? So this double underscore, and you'll see double underscore name as one of the things present over here. So it's a special attribute actually, double underscore name. I'll remove this. So just think of what we're doing here, right? In this wrapping function, we are printing the function name. We are printing the starting time of execution by calling this GetCurrentDateTime, which is this function. Then we are executing the original function, which is this getting the Steve Jobs quote. Then again, we are printing the function name and the execution end time. And then we're passing control back to where the function was called from. So when I say this is the original function, and I've used this at datetime logging decorator in the line above it, it means that this function has been passed into this datetime logging decorator, and this function is what I get as the output, right? So this entire code gets executed and not just this code. So let's run it and see what that looks like, right? So I'll copy this and I'm going to run this. So you can see that there's a function name, there's a start time, then there's a output of this function because the function is executed here. Then there's these two lines after where it says function name and end time. So let's say I didn't want to change the original function. Let's say I didn't want this decorator. So all I would have to do is comment out this line where I applied the decorator to this function. So now there's no decorator applied to this function. So just the original quote should enter. Here we go. I have just this original quote. But if I now apply this decorator to the function, I get this pre-processing, then the original quote, and then the post-processing, which is basically this function that gets returned. So the decorator took our initial function as the input and returned a modified function as the output. But the modified function is referred to by the same name as the original function. So let's do an exercise here to understand this better. Define a function that prints the squares of the first 10 non-negative integers. So what are the first 10 non-negative integers? That's 0 to 9, right? So I'm going to say define first 10 squares as my original function, and it prints the values of the first 10. So I'm going to say for I in range 10. So it basically gives me numbers from 0 to 9. Print I square, right? So this is my original function. Now define a decorator to modify this function behavior. So I want to print a message at the beginning and I want to print a message at the end. And you can see that this function doesn't take any arguments. It doesn't return any value, right? But I need to do some pre-processing and some post-processing. So let's define the decorator function, right? And we know that the decorator thing is a function. So define print message decorator, right? And what does the decorator take as an input? It takes a function. Let's call it func. And now in the decorator, we define an inner function which contains the entire modified behavior. So define inner function, or let's say new func with modified behavior, right? And that doesn't take any input because this doesn't take any input. So now in this new behavior, what exactly do I do? I say beginning of print before executing, then I execute function, right? Which in this case is this particular function, but it can be any function. Then I print the statement at the end, right? And from the outer function, that is print message decorator, I return this modified function, right? And I return the function object and not like the value from that function, right? So I have defined this decorator function that does what I wanted, and this is the original function that I've defined. Let's see what happens if I call just the original function without applying the decorator. So I'll say not even print, I'll just call it first 10 squares and just execute it, right? So I'll run and I get the squares of the first 10 non-negative numbers, that is 0 to 9. Now, if I apply the decorator by saying and decorator function name, right? Now what happens is I'm saying I call the function by the same name, but I've applied this decorator to it. So what I'm actually executing is this. So now if I call first 10 squares, I get beginning of print, then I get this function output, and then I get end of print, right? Which is exactly the contents of this function, this modified behavior function. Okay, so I had already told you in this example, this original function does not accept any arguments and it does not return any values, right? What happens if it did accept arguments? So now let's say I define a decorator that repeats the execution of a function twice, right? And as usual, this outer function takes a function as input. And then there's a wrapping function here that all it does is it executes this input function twice. And then we return this wrapping function, right? So this is a very simple decorator called the repeat twice decorator. And we're defining an original function called print message that takes a message as input and it prints some message as the output, right? So I'm going to print message with this particular input. So the first thing I'll do is I'll run this and let's see what happens. I'm going to say enter. Okay, so I'm going to run this, and what I expect is that an error gets thrown, right? Why did I expect this error to get thrown? Well, the simple reason is my original function took an input, right? It took an input and it printed a custom message based on that input. Now, when I apply this decorator here, it's returning a function, which is this inner function that does not accept an input, right? So here the arguments are empty, which means that it doesn't know what to do when I call this original function with an input. And how do I deal with that? Right? So what I have to do instead is I have to find a way to accept arguments in this inner function, this wrapping function, right? And I've covered this in the previous module where I told you to accept a variable number of positional arguments, I use star args, and to accept a variable number of keyword arguments, I use double star kw args, right? So by passing this generic kind of, or rather by defining the wrapping function as accepting these both these types of inputs, what I'm saying is I have covered my bases for any kind of input that the user provides, right? So irrespective of whether I say print message 123 or print message ABCDEF or print message whatever, right? That entire set of arguments fits into this structure. So how do I access the values in args? Either as a tuple or list, right? So I iterate through it. For arg in args, I'll print this. So for individual item in this list variable or tuple variable called args, I'll print it, right? Similarly, for all keyword arguments in this variable, and this variable is accessible as a dictionary, right? So printing this will give us key value pairs in the dictionary. And if I wanted only the keys, I would say kwargs.keys. If I wanted values, I would say kwargs.values, right? And now when I execute this function inside this wrapping function, I pass the same inputs that I got over here to this original function. So I have not just passed the original function to this decorator, I have also passed these inputs from this wrapping function to the original function. And I called this decorator basically repeats it twice, right? So in both cases, I'm calling it with the same arguments. So let's see what happens if I now run it using this revised decorator function. So instead of just executing func without an input, I will now say I'm passing these variable number of positional arguments and variable number of keyword arguments. So if I pass nothing, anyway, these items are empty, right? And the same thing gets passed over here. So in effect, it's like passing it with no arguments. But if I did pass arguments, then they get captured over here and get passed on to this function over here. So if I run it now, I can see that the message is printed correctly, right? So this is the message I expect to get printed. And the function is executed twice because I've applied the repeat twice decorator to this print message function. So I hope you understood that clearly. In the original case, I didn't have to do anything special because I had a function, the original function, that did not take any inputs and did not return any outputs. But now when the original function takes an input, I need to make sure I define this wrapping function in a way that also accepts inputs. And the way it does that is using the star args and the double star kw args objects, right, which we saw in the previous module. So if you have doubts about that, please go through the previous module and you can look at it in the part on arguments to functions. Let's do an exercise now to cement this understanding. So define a function that takes an input name from the user and prints a particular message along with the name. So I'm going to say define uh, print custom message as our original function, right? It takes an input name. So I'll say input name from the user and it prints a message, right? So there's still no output returned. It just does some processing, which is print a message. And this message is the name you entered is plus input name, right? So that's all the function does. Now, if I call this function from the outside and I'll just say print custom message of, and the input that I pass to it, I'm going to ask the user for some input, right? Saying enter your name. So the name that the user enters is stored as a string. That is the variable or the value that I get from the input function. And that string is passed to the print custom message function, which then prints this custom message. So if I run this, it asks me to enter my name and I'll say Vikram. And it will print out this message saying the name you entered is Vikram, right? Which is the behavior we expect. Now let's say I want to define a decorator function to execute this original function thrice. So I'll say define repeat thrice decorator, right? And what does it accept? It accepts a function. In this case, we'll be passing our original function to this decorator. Now, what does this decorator do? It executes the original function 3 times. But this original function also accepts an input. So we need to make sure that this inner wrapping function also accepts an input. So I'll say wrapping function, it takes the input, right? Now we don't know exactly what the input is going to be, because today I could be passing this function to this decorator. But if you think about it, a repeat thrice decorator should be able to repeat any function 3 times, right? Not just this one. Now, this function accepts only one input, but there are other functions that could accept two, three, four inputs and so on, right? So we need to accept any possible number of inputs. So the way I do that is the user could either specify positional or keyword inputs or a combination of both. So I'll handle both. So I'll say star args to handle the positional arguments and double star kw args to handle the named keyword arguments. Now I'm going to execute the original function 3 times. So I'm going to say func of, and I'm passing these same inputs to the function, right? Whatever I get from the user, I'm passing these same inputs to the function. And I'm going to execute this 3 times, right? And that's it. That's what the wrapping function does. And now inside this decorator, I'm going to return this wrapping function. The function object, not the value from this function. So now how do I apply to this decorator to the function that I had initially defined? I say at repeat thrice decorator, right? So now this repeat thrice decorator is applied to this original function that worked in this particular way, right? So now it should get executed thrice with the input that I entered only once. So let's run it again. It asks for my name. I'll say Vikram. And you can see that this message got printed 3 times. So I've successfully applied a decorator to an original function that accepts an input, right? It has one input argument. Now, this function still doesn't return a value, right? What would happen if I returned a value from the function? So this wrapping function accepts arguments and then passes on these arguments to the original function, right? But what if this original function returned a value? Then the wrapping function would also have to return a value, right? So let's say my original function is this, right? Which is print and process a message. Now this message, either we can pass a string or we can ask the user for an input. So what the function does is it prints the message and it returns the length of the message. So there is an input argument and there is also a return value, right? So since we are kind of replacing the contents of this function with the wrapping function also needs to have a return statement. So here, in this particular case, it's only executing the function, right? It's not returning anything. So the default value that gets uh, returned from a function that does not have a return value is none, right? So if I say len of message, I should basically be getting none. So let me run it here. So len of message equal to print and process message, but not just the original version of the function, it's the decorated version of the function. So if I run it, I get the value none, right? None because there is no return statement here. So how do I address that? How I address it is, instead of just executing the function that I've passed, I will return this particular value. So if I execute this function, it prints out a particular value and it returns a value, right? So that value that gets returned from this function call, I'm returning from the wrapping function. So just like I passed arguments from the wrapping function to this original function, the return value from this function is passed inside the wrapping function and given back to where it's called from. So if I change the decorator function now to this new function where I have a return value, the original one didn't have a return value. So from none, I should get the actual length of the string, right, which is 18. So you can see that by just adding this return statement here to this function call, I'm now returning the value that is sent from uh, the original function, which is the length of the message. So just like whatever argument I pass to the wrapping function passes to the original function. The value that the original function returns is returned to the wrapping function, which in turn returns it to us. So let's do an example here. Define a function whose first argument is positional and contains the input message obtained from the user, right? The second argument is a keyword argument named n. The function prints out the input message n times and returns n times the length of the input string. So let's define this original function, then we'll talk about the decorator to modify it. So define echo, I'll call it echo len, right? And it takes a message and it takes the value n, right? And what now happens is it prints out the message n number of times and it also returns n times the length of the message. So it's a very simple function, right? So if I now what the function does is we're calling it in a way that the first argument is positional and the second argument we're passing as a keyword argument, right? So I'm going to say print. Now let me just store the message from user equal to input. I'm asking the user for input. Enter your message, right? Now I'm going to call this echolen function because there is a return value. I'll call it from within print echolen of two things, right? One is message from user and the other argument I'm passing as a keyword argument. So I'll say n equal to 5. So the first argument is positional, that's just a variable. And the second argument is a keyword argument, so I'll say n equal to 5. Now if I run this, it asks me to enter the message. I'll say test message, right? It echoes this 5 times and it also returns the length of the string into 5, which is 12 into 5, that gives 60. Right? So I called this echolen function using one positional argument and one keyword argument. Okay. Now I'm going to keep the structure the same, but I want to modify this function's behavior, right? So I want this beginning of print before the execution and end of print after the execution, right? If you remember, I had already defined this decorator somewhere on top in one of the exercises. It's okay. Let's just write it again. So I'll say define print message decorator, right? That accepts only one input, which is the function to be modified, right? Now we have a inner function, the wrapping function, right, which accepts any arguments that you can provide. It's not fixed to only positional or only named or keyword arguments. So star args, double star, kw args, right? It accepts all possible inputs. Now it prints a statement called beginning of print, right? Then it executes function with these set of arguments that it's received. Then it prints a message right at the end called end of print, right? And now I'm applying this decorator to the original function. So let's see what happens here. So I'm still calling this original function, but now it should demonstrate the modified behavior. And if I run it, I'll say test message. It throws an error, right? Why is it throwing an error? Oh, sorry. What I had done was I had not returned this wrapping function back to the original place where the function was called, right? So let me remove this and just show you what happens. So the message is test message. And what happens here is what gets printed is the value none, right? The value none gets printed over here. That's because I'm just printing beginning of print, which is here. I'm executing this function which prints this message n times. So it prints it 5 times. It returns this value, but we're not doing anything with this value here, right? And then we're printing end of print, right? And I told you if there's no return value in a function, by default Python returns none, right? So the value that gets returned over here is none, and that's what gets printed. So if we wanted to like return the value from this function, we would use the return keyword here, right? So it would return everything that is returned from this function call. So if I run it now, I'll say test message is my input. It says beginning of print, which is what we expect here. It executes the function, and within the function it prints this message, which is what we expect. It returns the length of the message, which gets printed here, which is 60. But the weird thing is it didn't print end of print, right? The reason why that actually happens is because return, as the name suggests, returns a value and passes control back to where the function was called from. So if I have returned this particular value, it means control has passed back over here, and any statement after the return is ignored by Python, right? So end of print basically got ignored. So what I could have done instead of that was I could have created a variable called x that captured the value of this return value of this function. Then I would print end of print, and then I would say return x, right? So now if I run this, I get beginning of print, I have my function execution, then I have end of print, and I have the returned value from the function over here, which is exactly what I want. Okay, so remember, this function is accepting an input, which is the input that the user gave. It's also accepting a keyword argument where n equal to 5. It is also returning a value, which is the value it got from this function execution, the original function. So this is how you define decorators. So you can see like how I can easily extend these decorators. Right now I'm just printing a simple message, right? But tomorrow if I wanted to do some heavy duty like API rate limiting, or I wanted to implement authentication, or I wanted to perform caching, right? I could have done any one of these things by just passing the original function to a decorator. That is a wrapping function. So in that way, I kind of modified the behavior of the original function. So in this module, we've covered nested functions, we've covered closures, we've covered variable scope, and we've covered decorators. So just to reiterate, in nested functions, we need to remember that whatever's on the outside can be accessed inside and not vice versa. And there is the order in which Python searches for variables is local scope, followed by enclosing scope, followed by global scope, followed by built-ins, LEGB, right? And a variable can only be accessed in its current scope or outside, but not further inside, not one level deeper, right? So a closure is a specific instance where of a nested function where the outer function returns an inner function that remembers some variable value from the outer function. So it's like a factory function that returns a version of the inner function containing a particular value which has been fixed, right? And a decorator in turn is a case of a nested function where we modify the behavior of a function uh, and change it in a particular way. Like, so instead of accepting a random input, a decorator function accepts a function as the input and returns another function containing the modified behavior. So that brings us to the end of module 5, functions. We'll see you very soon with the video for module 6, where we look at list comprehensions and generators and so on. See you soon.